Hello everyone, we're going to cover exercise 43 in this video, which is about theory B, from area to scale factor, and that's exactly what we're going to do at the first sub-question. They say two enlargements are made of a photograph measuring 10 by 15 centimeters. The area of one of the enlargements is 8 times as large. Calculate the dimension in centimeter of this enlargement. Dimensions are the length and the width, round to one decimal place. Well, if the enlargement is 8 times as large, then you could say that k squared is 8. And that would mean that if I want the normal scale factor, that would be the square root of 8. The book says this by saying, well, if one of your if the area is p times as large, then my scale factor is square root p. Yeah, that's the same as I'm doing right here. But technically they're correct, but I like more. They say the area is 8 times as large. We're talking about areas that are larger, then I'm talking about k squared. I like that more. It gives me the same result. And we're not using k squared to calculate dimensions, right? Because dimensions, we just need the normal scale factor. So now that I know that my scale factor is square root 8, that means that my new dimensions are going to be square root 8 times 10 and square root 8 times 15. That's where I started with, right? 10 and 15. And they want us to round to one decimal place. 10 square root 8 is going to be 28.3 centimeter approximately. And the other one is going to be 15 times square root 2, or square root 8, sorry, which is 42.4 centimeters. Right, so that's A. Remember, we're talking about an area that becomes 8 times as large. That means we're talking about k squared. And to go from k squared to k, I take the square root. Or do it as the book says to do it. Say if something becomes p times as large, this time 8, then the scale factor is the square root of p, square root of 8. The longest side of the second enlargement measures 25 centimeters. Calculate the area in squared centimeters of this enlargement. So they now gives us a dimension again. The longest side is 25 centimeter. Remember that I can calculate a scale factor by dividing a distance in the image, this is the image, the new thing, 25, by a corresponding distance in the object where I started with. This is the longest side, so here I also take the longest side, which is 15. So I do 25 divided by 15, which gives me a scale factor of 1/2/3. Or you can say 1.66666, but it's exactly. What is going to be the area? Well, for area, we need k squared, right? So now we square this number. And then we find k squared. If we're talking about area again, always think in k squared. Dimensions, we use k. So we're going to square this, which gives me 25/9, but maybe I do in this case round off a bit, 2.778, because in the end I also have to round. What's the new area? Well, area of the enlargement of the image, you could also say, is k squared times area object. So it's going to be 2.778 times the area that I started with. What do I start with? 10 times 15, right? Then times width. So that's going to be this times 150, which gives me an area of 417, because I have to round to the nearest integer, squared centimeters. So remember, use k when we're talking about dimensions, the scale factor. If we're talking about area enlargements again, we have to use k squared. And I can go from k to k squared by squaring it, and vice versa. I can calculate square root if I want to go from k squared to k. Okay, good luck.